Okay, so last video we went over rational roots theorem and I showed you this insane proof that kind of showed you basically how P and Q are related to that constant term at the very end, that A0, as well as the first term, the AN, in a polynomial. If that was confusing, we're going to simplify it a little bit and just kind of show you the rational roots theorem applications, how you can use the theorem, okay? So this is really important to solve the problem, so let's do it. Okay, so we're going to start with our polynomial f of x right here, same as the exact last video that we showed. If you remember, an minus 1, a1, a0, all the coefficients are integers. It's very important that they are. So if you ever come across a problem that does not have them as integers, you cannot use rational roots theorem. Muy importante. Okay, that's the first thing I want to say. Next one, rational root. Any rational root, any possible rational root is equal to P over Q. Okay, if you remember from last time too, P and Q are co-prime, which means they only have a common factor of 1. It's only 1. Within themselves, they're prime. Okay? If you didn't count any other, never mind. They're co-prime, meaning the only common factor they have is 1. Okay? P is equal to a factor of A0, and Q is equal to a factor of AN. If you didn't understand the proof, that's fine, as long as you understand that this is true. Okay, based on the rational roots theorem. We're going to do a really simple example to kind of show you how to use rational roots theorem, and I'm just going to use a really simple quadratic, which is still a polynomial. It's just a polynomial with a degree of 2. So I'm going to use rational roots theorem on this to figure out what the root of this polynomial was. And remember, root means that the function is when the function is equal to 0. So I'm going to put a little equal to 0 there to kind of help us out. Okay, so first thing we want to do is write P over Q. Okay? So I did that. P, so I'm going to fill in what P is right here, is going to be a factor of A0. So we're going to look at our A0 term, which is this negative 4 right here. Okay? Negative A0 is equal to negative 4. And we need to think of all the possible factors of negative 4. Okay? Well, let's make a list. We have 1 and negative 4. We have negative 1 and 4, we have 2 and negative 2, and we have negative 2 and 2, which these are kind of the same, so it doesn't really matter. Those are all the possible factors that we can use for negative 4. So what we're going to do, if you kind of notice, there's a little shortcut that we can do to write these down. All I'm going to do is, you see how there's a positive 1 and a negative 1? I'm going to write plus or minus 1. That's what that is. Comma, and then I'm going to write plus or minus 2, because as you can see we could have positive 2 or negative 2, so I'm going to put that in there. Okay, make this line a little bit longer. And then there's positive and negative 4, so I'm just going to do plus or minus 4. Okay, so from there, it's really easy to see. If you just want to think of the 4 as a positive, and just think of any of the factors as positive or negative of that number for each of the factors. So that's basically what I did. You just looked at the 4, and I know that it's going to be 1 and 4, and 2 and 2, and I just put the plus and minus for all of them. Just covers all bases. It's a little bit easier. Okay? We're going to do the same thing for Q, only this time Q is a factor of AN. Okay? AN is equal to 1. There's a little invisible 1 right here in front of that x squared. So we need to think of all the factors of 1. Okay? Well, we have 1 and 1. That's easy. And negative 1 and negative 1. So the same rule holds true. All we have to do is think of the 1 as a positive and just think of all the factors for that 1 positively, and then just do a plus or minus on it. So plus or minus 1. Simple. Okay? I'm going to erase my work here to kind of keep this a little neater. Okay? From here, we're going to do a little bit of math. It's pretty simple though, because we're just dividing some positive and negative integers. Okay? So, remember, these are possible roots. Not all these are going to work. We're going to figure out which ones do work. Sometimes none work. Sometimes no rational roots exist. Sometimes it's only irrational roots or complex roots. Okay? We're going to see if any of these work. Some will not. Watch. Okay, first thing we're going to do is positive or negative 1 divided by positive or negative 1. Okay? Well, if you do positive 1 divided by positive 1, you get 1. Or if you do negative 1 divided by positive 1, you get negative 1. Either way, no matter what combination you do, you're going to end up with positive or negative 1 as one of the possible answers. Okay? Let's do the same thing with positive or negative 2. You're going to end up with positive or negative 2 divided by positive or negative 1, which ends up being positive or negative 2. Okay? Let's do the same thing with 4. Positive or negative 4. Now this one's a little bit easy because that coefficient, that an, in front of the x squared is 1. It's not always 1. I'm just using this as a simple example. If you need help at any of the practice problems, see me if you get confused because there's a number in front of that, that x squared, or there's a number that's not 1 for the an term, or the an coefficient, I'm sorry. Okay? Now we need to see which of these actually works as a possible root. Okay? Let's start with positive or negative 1. Okay, this is kind of easy, so we're gonna do these in our heads. So if you take positive 1 and you square it, you get 1. Minus 4 is negative 3. That's definitely not 0. So positive 1 will not work. Now since this is quadratic, you should be able to see that negative 1 won't work either, because negative 1 squared is 1. 1 minus 4, still not 0. So we know that this is not a root for this polynomial. So I'm just going to put an x through it. Doesn't work. Okay? I'm going to skip to this positive or negative 4. Let's try that out. Positive 4 squared is 16. 16 minus 4 is not 0. So it's definitely not positive 4. Let's try negative 4. Well, since we're squaring it, it's going to be 16 again. Minus 4, it's not 0. So we definitely know that it's not positive or negative 4. Let's try positive 2. Positive 2 squared, as you guys probably can see now, is 4 minus 4 is 0. So we definitely know it's positive 2. Let's try negative 2. Negative 2 squared is 4. 4 minus 4, 0. So we know that the possible roots for this is positive and negative 2 for rational roots. Okay, I'm going to show you how to do the other kinds of roots, the complex roots or irrational roots, at another time. But for now, this is just for rational roots. Positive and negative 2 are rational numbers. These are rational numbers. So that will work for this. Let me know if you need any help on the practice problems. I hope this helps make you guys understand rational roots theorem a little bit more. All right.